For those of you who were in the last conference, the panel with the folks over at Brave and people from Zcash and Penumbra, we were discussing a lot about how there is this phenomenon today on blockchain that essentially blockchains are getting to specialize into doing one use case very good, maybe some other use cases somewhat good, and then choosing what not to do. And we noticed early on that because of this phenomenon, there was always going to be chain diversity. And the problem of chain diversity is that all of the permissionless attributes chains usually have do not translate well to moving between them. They do not cover you moving between two chains, and that's why we've seen the development of these centralized exchanges. Now, my problem with that, when we ended up founding Maya Protocol, is that this totally breaks the core tenet of blockchain that started with Bitcoin's white paper of peer-to-peer cash, which is permissionlessness. You should be able to move freely, not only within a blockchain, but between blockchains. And that's essentially what we set out to do. Well, what we did already 3 years ago was started to fork Thorchain's code. Thorchain, like Maya, is a cross-chain AMM DEX. And essentially, what we're trying to do is reach as many blockchains as we can and as many use cases as we can, so that we can permit people move freely between chains as well in the same permissionless setting as they would usually do when they're moving within a chain. So yeah, it's based on Cosmos SDK as well. And what we have essentially is a network of nodes who bond collateral to then be able to protect assets from liquidity providers that then permit users like you to just swap across. What would this look like? Well, simply like a Bitcoin to ETH swap or an ETH to ZEC swap in the future. Think Uniswap, but cross-chain. And today we support Arbitrum, Bitcoin, Dash, Ethereum, Kujira, Thorchain itself, so we can aggregate with other assets supported on Thorchain, and Radix. And what we are looking to launch in 2025 is Zcash, Cardano, and Caspa. And of course, more with many years to come. So essentially all the time what Maya is doing, and I'll have a very didactic video to show in a second, but all the time there's swaps coming through, like this USDT to Bitcoin swap, and they're happening all the time. You can check it out on mayascan.org. And I took this transaction as an example. And the interesting thing is that you don't really need to have Maya or Kakao, which is our native coin, to use these DEX. You don't need anything except your money in the source chain and the address you want to send it to in the target chain. So in this case, someone had some Bitcoin and wanted to receive some ETH to this address. So what they did was just use Edge Wallet to send some Bitcoin, and Maya will observe this. From the memo, this communicates to Maya what to do with it, and we know they want Ethereum sent to this address. So we do that swap logic internally and send the user the ETH. Now, the very beautiful thing is that Edge Wallet also included what we call an affiliate fee. Edge Wallet said, look, and I'm sending this user, please pay me 75 basis points on the swap. So the user in Edge Wallet is paying Edge for the service of providing this functionality within his wallet. So Maya is not only this way for permissionless movement between protocols, but also a way to monetize wallets, and this incentivizes wallets to bring this functionality to your favorite wallet out there. So we're talking about, we'll see some wallets that already currently support Maya. There's more coming in the future, but also for you guys, Sashi users out there, Sashi could have, they're working on being able to swap ZEC to BTC, and this will be a very brand new private way for Sashi to monetize the wallet and fund its continuous development into more privacy features for you guys. Yeah, essentially you can also here see some stats before I go to the video. We are able to process millions of dollars of transaction volume per day. And this is all enabled by our validator set, which is right now around 35 nodes that are over collateralized. The code allows today to have up to 120, and over the long run, we'd like to have 250 or more. And these are all anonymous nodes that, again, are over collateralized, protecting liquidity provider assets to facilitate these swaps. So with that all out of the way, I'm going to show you a short video that we created. I actually presented this in January in Cancun with the ZCash team. There at the developers summit, and our team made a video out of it, and I think it's appropriate for today's setting. So hope you enjoy.
Have you ever wondered how Maya works? Let's take a look at the life cycle of a transaction. Imagine we have 3 blockchains. ZCash over here creating blocks, Maya also creating blocks, and finally Bitcoin. Maya constantly monitors what's happening on ZCash through Bifrost, a bridge that connects chains and where validators monitor the vaults, which are Maya's addresses on external chains where funds are kept. Now, here's what happens when a user sends a transaction to Maya. They send ZEC along with transaction fees. When a transaction is observed, validators begin reporting it from Bifrost to Maya. They wait until 67% consensus is reached among themselves and ensure all chain-specific requirements, such as confirmations on the observing chain, are met. How does Maya know what to do next? The answer lies in the OP return data embedded in the transaction. This data tells Maya, swap to Bitcoin and send it to this address. Here's what happens behind the scenes. Maya uses a ZEC cacao pool and a Bitcoin cacao pool to facilitate a double swap. It calculates the required slippage fee and the final output for the user. The user doesn't even need to know Maya exists. From their perspective, it's just a ZEC to Bitcoin transaction. Once the outbound is calculated, another key component enters the picture: threshold signature scheme. This ensures no single entity has full control. Instead, Maya uses distributed key signing to securely and systematically broadcast transactions to destination chains. With the required 67% consensus, completes the process by sending Bitcoin to the user through Bifrost. The outbound fee is subtracted, which is determined based on an internal record of fees paid over the past few minutes. This fee is then adjusted with a multiplier to provide some extra margin for variability. So let's recap. First, the user sends ZEC plus a transaction fee. Second, Maya processes the transaction, swapping ZEC for Bitcoin. And third, the Bitcoin is sent to the user minus the fees, all handled automatically by Maya. You don't need to support Maya as a chain, run a full node, or even hold Cacao to use it. Through Maya's API, you can get real-time quotes for transactions, showing how much the user will receive, also taking care of subtracting all fees. Ready to integrate us? Welcome to cross-chain technology. Welcome to Maya.
Yeah, so as you can see there, Maya protocol has a very clear way of how it works. And for those integrators out there or people with wallets, it's actually pretty simple to integrate. You can do a direct integration directly to the Maya node API that you can run yourself if you run a full node. But there's also 2 services that you can, actually now 3 services you can today use, which is one is Exchange.js. It's a library that abstracts a lot of this logic, and you can use, it's open source, it's free. Or you can use SwapKit or DKit, which are APIs that are even more powerful. They have a cost, so you can reach out to them and they'll facilitate even more the process of integrating Maya. They make everything seamless and easy to just plug in. And you could have literally Bitcoin to ETH swaps tomorrow. And as soon as we integrate Zcash, Zcash to whatever we support. So it's pretty exciting. We're very, very excited to launch Zcash soon, as we really believe on what ZEC is building. And this will truly enable easy onboarding of so many more users that today are stuck in Ethereum or Bitcoin and cannot easily move to ZEC or back. So looking forward to launching. Yeah, Maya protocol is entirely open source. You can look at a repo on GitLab. You can see what we are working on. There's, of course, many internal features along with the integration of new chains. And In our mayaprotocol.com website, you can go to ecosystem and see all of the user interfaces that today support Maya, and this list, of course, is growing, and you'll soon see Sasha here as well as soon as we integrate ZEC. So you can here go and click, and it will take you to the appropriate application. AsGardX, for all of you guys that love open source, AsGardX is fully open source, along with also Mocha, and the rest are varying degrees of open and transparent. Multisig is also open source, and if you are a fan of hardware wallets, KeepKey as well is open source, and they support Maya protocol, Cacao, and swaps. Edge Wallet is also a very good option, and I think it's very compatible with the Zcash ecosystem. So you guys can take a look here, and hopefully you give it a try. Swapping is really, really easy in these interfaces. It literally just, you connect your wallet through some means. It can be a key store, again, it can be KeepKey, multisig, which uses essentially it's like a abstracted multisig control wallet, which is an extension, and it will literally just give you the balance of the assets you have in different chains, and you will swap just as you would say on MetaMask or Uniswap, but this time it will happen across the chain. Of course, this will enable many, many more use cases for you guys. There is, for instance, the case of Aaluxx, which is a guy that's been living in crypto for several years now. And a problem he usually has is, he'll get paid in Dash, and now what to do? And maybe he wants to be able to spend privately in some store to buy a cup of coffee, and he cannot. Now, with these swaps, that will, of course, enable many more use cases and accessibility to him, and just options. And of course, options is important for freedom. So yeah, that's pretty much what we do. You can take a look at Maya Academy to see some more resources on what we're doing. Today, we're working with Han from Y Wallet, people from Zcash Core, and from the Zcash Foundation to finalize a few details of the Maya integration of ZEC, and hopefully it will be done and launched in the next few weeks. We really wanted to have it ready for this event, but some things have been delaying it. Specifically, we're looking to reduce dependencies of external code and make sure that it's as synchronized as possible so that the user experience is on point and hopefully pleasant for all of you guys. Yeah, essentially the rest of the time, I'm very open to answer questions. We answered quite a few of them in Cancun with the developers. So yeah, first question we have is with Maya, will it be possible to also earn fees by adding liquidity? And what are the risks of the user? That's a great, great question. We have pools here. Per asset, you're always adding liquidity of your chosen asset and Cacao, and you earn some APR on that. Now, importantly, APR here are backwards looking. Maya does not make a statement about future performance. It will entirely depend on swap volume. Maya doesn't have emissions, subsidies, hidden ways to pop up the APR. It's just literally from swap fees from users. So these will go up or down according to chain usage. Also, a risk you have is you have Cacao exposure. Thankfully, Cacao was fairly launched. Again, it's all fully diluted, and it's generally just a very healthy asset in a sense, but it can still go up and down according to market, user sentiment, etc. You also have impermanent loss, and this is inherent to any AMM. So by adding liquidity, you're of course hoping that the APR will outrun the impermanent loss incurred in the pool, but that's a risk that you have to quantify for yourself. And finally, you have the risk of Maya getting hacked. Now, Maya holds all of these assets in just regular wallets that are protected by threshold signature scheme. Specifically, we use GG20 today, an implementation of Go TSS by Binance. in an open source library that's available and audited. And now it could happen that there's a vulnerability either in GG20 or the specific implementation of it, and someone gets access to forging a valid signature for the vault and stealing the assets in the vault. Now, that hasn't happened in several years of GG20 usage. And in any case, there are way bigger parties than us today using TSS. And if that were the case, we can probably respond, since we are not, we wouldn't be the first target. There's hundreds of implementations of Go TSS in GG20. And yeah, we also have a bug bounty in Immunify with paid bounties to security experts. One is actually a Zcash contributor as well. You might know him as Kayaba, and he's earned a few bug bounties for finding ways that this could be exploited, and we're of course actively looking to make it as safe as possible all the time. But those are the main risks, and it's for you to quantify and choose whether this makes sense for you. But we hope that it does, and we hope to see you LP on Maya. What was the most challenging aspect of the Maya Zcash integration? Well, there's one thing going for us and one thing going against us. One thing going for us is that it's Zcash mostly behaves like a typical UTXO, and since we already support Bitcoin and Dash, that made it a bit easy, or rather more straightforward than sometimes other implementations. Where we start getting into trouble is that Maya is coded in Go, and you have libraries of Zcash be in other languages. So porting that code over to Go has been the problem. We first tried to wrap these libraries and kind of use the code in that other language. The problem we got there is that there were sync issues, as Maya works very fast. And if these two programs were essentially unsynced, it would cause trouble. So in testing, we decided that that wasn't the optimal solution. So we had to discard a few months of work and restart work now by essentially finding those key functions that we need all the time of Zcash and porting them over to Go in a secure way. And that's why we got people from Zcash involved, Zcash Core, so that we no longer run into these syncing issues. And this also enables us to have fewer dependencies and a better integrated code. But that definitely is what has set us back a bit. Aside from that, it's been a great experience, and we truly admire the work that the various Zcash teams are doing. You can check here on MayaScan a lot more information, also just about the state of the network. Right now, there are 38 active validators with 19 on standby. What we actually do is we constantly churn our validator set, where every 8 days, a few validators will be kicked out. The worst performing one, the one with the lowest collateral posted as bond, and the oldest one. And we create new vaults, TSS vaults, with a new set of validators. And now all of the funds are migrated from the previous vault to the new vault. Now this accomplishes several things. Number one is we make sure we have a certain level of liveness, right? We don't have inactive validators, as those would very quickly be kicked out, securing these vaults. Number two is proof of liquidity. We not only show that we have the balance required to collateralize and to fully commit the pool's assets, but also we show that it's all spendable, which is a very important thing that many central exchanges cannot really prove. And finally, we're making sure the distributed key is constantly changed, such that attacks that rely on slowly accumulating chains from different servers cannot be effective as every 8 days, essentially the problem starts again from scratch. So this is a very important characteristic of a liquidity network that's holding assets from other chains. And you can see here a countdown of when the next churn event will happen. The nodes that churn in are actually the ones that post the highest bond. So that way, we're also ensuring that there's a competition of sorts happening to belong to the validator set by having them bid the highest collateral to get into the set. Of course, validators also get a reward, and this is just also a percentage of fees. As I mentioned earlier, Maya has no emissions, subsidies, inflation whatsoever. So all of this is entirely happening from the rewards of the swap fees. So it's all real yield. Now, these validators, since they post collateral, if they misbehave, depending on the transgression, some of it can just have slash points that will go against the reward, whereas others, like stealing assets or doing a double signing event, we can then go to the validator's bond and subtract their bond from what they stole. So far, in 2 years of operations and 10 million blocks, this hasn't happened. Since the incentives are aligned, not only do you get rewarded for doing validating the right way, but you also get punished for not doing so. All of these validators are relatively heavy. Most of them are hosted in bare metal servers around the world. It's heavy because they have to run their own full nodes in each of the supported chains. So you can see here that they're running and observing successfully in every single chain. We have here a validator that's behind in Arbitrum. Arbitrum is relatively heavy and fast chain, so that makes sense. But we can see here that that user is also the one that has accrued the most slashes out of the others in the set. So this validator will surely be churned out next churn in exchange for a better performing validator. While being out of the validator set, these nodes can, of course, look at the performance of their full nodes on Arbitrum, look to improve it, and thus maintain their place in the validator set for the next churn. Now, this is, again, very much in the weeds of how it works, and I know the ZCash community is one of the most sophisticated out there, so it's good to get into the details, but it's something that the user doesn't really need to know. The time dimension on Maya, because it's a cross-chain AMM, is very short when compared to a bridge. The user has Bitcoin, they want ZEC, they click a button, and in just a few minutes, they have the ZEC in their wallet. It's self-custodied, it's under your key. So you didn't really have to trust Maya at all, except for the few minutes that the swaps happened. So the trust assumptions, because of the time horizon being so small, is therefore also very small. Whereas in a bridge where you're having pegged assets or wrapped assets, you have the risk of the latent risk of the bridge going down, and that affects users that had not yet swapped out of the wrapped asset or unwrapped the asset. And all of that TVL, wrapped or pegged TVL, is at risk. Well, here the normal user is not exposed to any risk of Maya as soon as a swap is finalized. So this is a characteristic that gives AMMs, cross-chain AMMs, different use cases than bridges. Of course, there are use cases for both. Bridges tend to be cheaper or give an asset a quality that it didn't have. So when you have wrapped BTC on Ethereum, now you have programmability that you didn't have in Bitcoin. Or when people perhaps bridge or issue tokens as a ZSA on Zcash, now they will have privacy characteristics that perhaps ETH didn't have when it was in its native chain. So this is where bridge becomes useful. But when you just want to move across a chain, having the shortest time horizon of trust options is the best, and that's what essentially Maya achieves. Now, over on our website, you can scroll down and get involved in our Discord, X, or Telegram communities. On Discord is definitely where you'll find the most detailed and the most active members of the community. You can get involved as a developer and get bounties for contributing different things. And you can, of course, if you like what we're doing, go to X and share our work. And yeah, the reason we're building this is because we truly believe that permissionless is the most powerful thing that Bitcoin brought to the world, and Zcash continues, and we have to bring this also to move in between. Has there been any consideration of CSA support? Yes, and at least in the current design, they're not able to be implemented, although in the future maybe they could. The reason for this is that our vaults are transparent. So as I mentioned earlier, we control vaults on Bitcoin, we control vaults on ETH, we control vaults on every chain we support, and we will be controlling vaults on Zcash, as the note said, with this distributed key. And a very important characteristic of these vaults is that they're transparent, so that any user, integrator, liquidity provider, wallet can verify that the assets that Maya claims they have is really what is in the vault. And also, because we're permissionless, any node can then join the network and can verify the history that everything has been working appropriately from the past to the present. So for this to be conserved, we do need to have either transparent vaults or have a way to fully open private vaults. Now, although there is a way that these keys could be published, it does add a lot of complexity, and it's still unclear whether we would be able to have all of these function. Where we have the biggest Achilles heel in all of this is that Maya today does not support Frost signatures. We just support direct ECDSA, and very soon we will support EDDSA, but not Frost. So Maya would have to support Frost and then make this added complexity of having these private vaults where we share the keys to the public so that the vaults retain these transparent characteristics, and that wouldn't be possible to launch this year. So to launch this year, we are going with T addresses for the vaults, and in the future, 1-2 years from now, if it seems that T addresses will be retired, we can jointly with Zcash put in the work to support private vaults, and supporting private vaults would yield supporting CSAs automatically. Yes, supporting having a full viewing key for the vault would be useful, is what I mentioned earlier. Again, it adds some complexity, but even if we wanted to go that way, since Maya doesn't yet support Frost signatures, it would not work. These private pools use strictly Frost, and the transparent addresses use just plain ECDSA. And since we use ECDSA, that's what we are forced to use at this time. But again, putting in the work for Frost and then doing all this system for having nodes when they broadcast the vault address, also broadcasting the viewing keys, such that we retain those transparent characteristics, would do the trick, but it would require a second phase of this work. Great question, by the way. I'll be waiting for a few more questions since we have 10 more minutes, and then we can move on. I hope you guys have enjoyed what we've been working on. It's been 3 heavy years. To be clear, everything about the protocol is permissionless. So you don't need permission to become a validator. You just have to create your node address, run your own node infrastructure, and LP, and post that liquidity as bond. Once the bond is provided, if you're the highest out of the standby validators with the highest bond, like these guys here, you will be able to churn in every 8 days. Alongside it, adding liquidity is permissionless, swapping is permissionless, and also contributing to the protocol is permissionless. What does the integration process look like? That's a great question. Essentially, you have to first support the source chain you want. So if you want to swap from Zcash to something, then you need to support Zcash, wallet balances, sending, signing, all of that. You don't need to necessarily support anything on the destination chain, since Maya will just take care of that logic, send the money to the user, and then the user can view it later when they open another wallet, for instance. But you at least need to support the source chain. So that's why Sashi would support swapping from Zcash, but not swapping to Zcash, unless they actually then support, for instance, Bitcoin, if they want to support Bitcoin to ZEC swaps. Now, as for the side of Maya, in the end, really, if you want to just go very bare, you just need to be able to know what the vault address is and how the memo looks like. And the vault address, you can query it on the Maya Node API. That, there's 2 endpoints for that in our documentation, or you can run your validator yourself, or just a full node, so that you can query it internally. So that vault tells you what today is the vault that Maya is observing for inputs of the swap, and essentially be able to sign a transaction in the source address where you send Maya the transaction with the appropriate memo. And the memos for that are, again, also in our documentation. Now, if you want to abstract this process or add more things like something we call streaming swaps, which I can explain in a second, then you can just use Exchange.js or SwapKit, again, to make this process easier, as in those, Exchange.js is a library, SwapKit is a library and a framework and API. Essentially, they serve you as a wallet integrator much more tools and information in a much easier way to integrate, so that you can put all these functionalities in your integration easily and securely. So you can reach out to those teams, or you can reach out to me and I can put you in contact with them, such that you use that in your wallet. Now, I mentioned streaming swaps, and it's actually a very interesting thing, because you might go to MyScan pools and see that not all pools are very deep, and be preoccupied about the price settlement that Maya can achieve for a swap. The great thing, though, is Maya has this thing called streaming swap, which essentially breaks down a swap into several smaller swaps and streams each over time into several blocks, achieving very small slippage for very large swaps. So we've even seen swaps that are twice the size of the pool depth be settled with less than 50 basis points of slippage. Yeah, essentially, we ideally would like to see the ZEC cacao pool be at least $500,000 to $1 million deep at launch, and it's something that is achievable between the different parties involved in this integration, and the talks we've had with some people interested in providing liquidity, and that should suffice to have very effective $500 to $1 million swaps across the pool. Of course, deeper is better, and would support having faster swaps in a sense. But we're doing a lot of things on our side to make things more capital efficient, and keep working on that price settlement and time settlement dimension. So again, these are Exchange.js and SwapKit. Or you can reach out to me. I'm Aaluxx Myth, just like you saw probably in the event, on X, or you can just reach out to the Maya_protocol profile, and they'll relay that message to me. We will be very happy to have you integrate us. we've got 4 minutes left, so probably just one more question. We get it published, and then we can wrap up. I know this is a lot of information, so feel free to also just post questions on X addressed to my protocol or to myself, and we'll be happy to answer them. I also highly encourage you to just try one of the wallets out and test a swap, $10, $20 of Arbitrum to Dash or whatever, so you get a feel of what it's like and what it will be possible to do over on Zcash. Earlier, as we were speaking also with the Brave people from Brave, Brave integration of Maya would allow not only holding ZEC, but also onboarding their users that use the Brave wallet functions to move freely to and from ZEC directly on Brave. So definitely that and many more use cases will be enabled once this Maya protocol integration is out. Well, it looks like there aren't any more questions, so I'll just wrap up here. First off, thank you to Zcash Core, Zcash Foundation, Han, and Josh for getting so involved in our work. It's been a pleasure working with each of you, and we've had nothing but great experiences. We're very, very excited about Zcash roadmap and to be involved with this great community and what you guys are building, hoping that we can bring something useful to you and bring value to you guys, as I really believe that not only is privacy normal, but privacy is a very important ingredient to freedom, and freedom is the most important ingredient for a prosperous society. So we're really looking forward for this to be rolled out. And welcome to Maya for those who are new here. Hope you have and enjoy a great experience using us. And hope that if you like it, you'll get involved. We need as many hands as we can get, either as users, contributors, providers of liquidity, of participating in the network, or any other way. As yeah, we really need this tool to make blockchain as a whole industry be permissionless, not only a movement within a chain. So really looking forward to having you on board, guys. Thank you for your time, and I hope you enjoyed today. Have a great one.